Hello. Today I'm going to run through one of the test versions. I don't remember which one this is, but this is for topic one. All right, so this is, I believe it's for second period. Okay. All right, so on the first problem, it's just asking for the maximum number of x-intercepts. All right. Well, the maximum number of x-intercepts is the maximum number of roots, and the maximum number comes from the highest exponent, okay, the largest degree. So you look for the largest degree, and that's why the answer is 5. Okay? And the second one, find the smallest real root correct to 3 significant figures. Okay, so this is when I would use my calculator. So let's pull this out. And the first thing I'm going to do is graph it. Okay, so here I'm going to plug in 3x cubed, get off that, minus 5x squared minus 4x plus 8. Alright, so then I graph it. Oh, I have my stat plots on, excuse me. Okay, so now you have this as your graph. Okay, so zoom standard. So then you want to find the real root. So that's going to be down here. It's an x-intercept. So you do second trace, and you use the 0 button. Okay, so then you just follow the commands. It says left. Where'd my button go? There we go. Oh, it went too far. Didn't even notice it. Okay, so left side, right side, and best guess. There we go. Our 0 is negative 1.21, but notice we have to round up. Okay, so 3 significant figures. Alright, so now this one, we want to find the intersection point. So we go into our graph, and we plug each one of those in. So we're going to have x cubed minus 1, negative, make sure you use the negative button, plus 1. And we graph that. So that was my first one, the x cubed, and my second one is a line, which is the red one. So we use our second trace. We use our intersect, so number 5. So we do our blue curve was our first one, and we do our best guess. Then we do the red curve. We go back and forth. Actually, that was pretty good where it was. Okay, and then my best guess is kind of like a free-for-all. I lost it. Okay, well, good enough. Okay, so the intersection is this, and notice it found it. All right, so the x-coordinate is 0.596. Okay, we leave it rounded to 3 significant figures. And then, of course, the y-coordinate would be right here, negative 0.788. The 8 does not get rounded up. All right, ooh, sorry. So for number 5, I would do this written out. So I would rewrite these without the parentheses. So you have 2 to the negative 3 times x to the negative 9 plus 3x to the negative 4. And then I'm going to put them as little fractions and move my negative exponents down. So I'm going to have 1 over 2 cubed x to the 9th. And over here, I'm just going to move the x down. So I have 8x to the 9th plus 3x to the 4th. So I want to have the same denominator, so I need to multiply this one by an 8. Whatever I do the bottom, I have to do the top because that has an 8. Then it needs x to the 5th, and here we go, 1 over 8x to the 9th plus, what is that, 24x to the 5th over 8x to the 9th. And that's how I notice that the A is 8. Number 6, we can rewrite this expression as 5 to the x times 5 to the first. If you don't understand this, go back and watch those videos. I've explained all this before. Okay, and just because they all have a second 5, I'm going to do another 5 to the 0, right? Because that's like x plus 0. You should know this. I'm not trying to explain it. I'm just walking you through what I did. So then I'm going to pull out a 5 to the x, since every single value has 5 to the x. So then basically I have 5 to the first plus 5 cubed minus 5 to the negative 1 plus 5 to the 0. So 5 plus 125 minus 1/5 plus 1. Okay, so we get 5 to the x times 130.8. Ooh, dropped my line there. Number 7, natural log of x. Hopefully you know the natural log is log base e. So we do our loop-de-loop. We get e to the 4th equals x. So then we just plug that into our calculator. So the e button is with the natural log, so second ln, and it already puts it as an exponent for me, so I just put 4. 54.6. Notice it rounds up. Number 8. Okay, hopefully you know that when there's no base, that's base 10. We do our loop-de-loop. We get 10 to the second power equals 2x minus 30. So then we get just a basic equation here. So that's how I get 65. Number 9. The first term is 3.4. The common difference is 1.7. Finding the 20th term, so finding the nth term, is this formula. So I want to find the 20th term, so that's represented by a sub 20, and I replace everything that I know. And since it's 20, n is 20. What is that? 1.7 times 19. 32.3 plus 3.4. I could have done that in my head. What am I doing? 35 points. And plus the answers were right there. Not really thinking that through. That's okay. Alright. So on this one, I had the wrong answer. That's why it's highlighted. I've since corrected it, so I should have given you points back for that. Okay. So let's see. We want to find the sum. So the sum formula is S sub n equals n over 2 first term plus the last term. I usually use this term, or this formula, but IB Math is going to give you another formula which you could also use. It's n over 2, then 2 times the first term plus n minus 1 times d. They basically replace this with the nth formula. Okay, so here, why don't we use this one, because we know what n is, and we know what the first term, and we know the difference. So we're going to do 30 over 2, 2 times 3.4 plus 30 minus 1 times 1.7. Okay, so let's see. I'm not worried about showing my work because I'm not turning this in, but you should make sure you show all the steps. But, oh, what am I? You have the answer right there. When you work all this out, you should get 84 or 841.5. For number 11, we want to find out how many terms. So the nth term, right? We know this is the first, this is the second, this is the nth term. That'll tell us how many are in line. So use this formula. And then plug in what you know. The difference, 8.2 minus 5. We don't know what n is, but we know the nth term is 75.4. So you solve this, and you should get n is 23. All right, for number 12, we wanted to find the difference. So if we take the second term and subtract the first term, that'll get us the difference. We can also get the difference by taking the third term minus the second term. So do that. We get 4k plus 2, that's the second term, minus the first term, 3k minus 3. That should get us the same thing as this minus the second term. Okay, so we solve it. So here you just want to make sure, I think a lot of people messed up here because they didn't distribute the negative. I don't know why I wanted to multiply that. At least I think that's what I did, because here it messes up and you get, yeah, I should have done the other form. We end up with k plus 5 equals, yeah, 5k plus 7 minus 4k minus 2, so we get k plus 5. So we get the same thing. Yep, it was a mistake there, but on the other one, you should solve it the same way and actually get a k value. But here, you get k equals k, so that's why it's all reals. Yeah, a little mess up on my side, but we should know that's what happens when we solve equations and we get something weird like that. Okay, so I dropped it on this one, but make sure you know how to do it. Okay. So we want to find the 10th term of a geometric sequence. So the 10th term, well, I guess you should know, make sure you're using the right formula. That is the first term times the ratio to n minus 1. So the 10th term is 180. The ratio here is we do 90 divided by 180, the second term divided by the first term. So that's how we get the ratio is 1/2. And then again the 10th term. So we solve this on our calculator and we should get that to 3 significant figures. Number 14, find the sum of a geometric series. So the sum is this formula. So we plug in what I know, or what we know. I think I messed up on the answer key before, and so that's why it's highlighted. This is the actual answer. So we want to do the first 12 terms. So we have 40, our ratio 60 divided by 40 is 3/2, or 1.5, to the 12th. And then 3 over 2 minus 1. So now I would just use my calculator, and you should get that. $15. Okay, so I messed up here because I put my answer as money. Some of you guys put it in pennies. I believe I went and corrected that and gave you points for that. But what we can think about is the first week. So in week 1, we got 1 penny. And week 2, we've got 2 pennies. Week 3 is 4 pennies. Week 4, we're getting the idea, right? We're doubling, right? Doesn't seem like I'm going to get very far. Okay, so we keep on going, and we want to find, after 2.5 months, so 14 weeks. So this is a geometric sequence. So the nth term of a geometric sequence is just this. So we want to find what's my rate in the 14th week. And my rate is just 2. My ratio is 2, same thing. And then 14 minus 1. So we use our calculator, and we should get, this is our answer. So in the 14th week, I'm making almost $82 a week. Yeah, I'd say that's pretty good. Okay, so now after 20 weeks, how much will I have saved in total? So we're going to use our sum formula. So the first term, ratio n minus 1. So plug in what we know. So the first day, or I'm sorry, the first week, 2 to the 20th minus 1 all over our ratio minus 1. We plug that into our calculator. We should get that. Number 17, I bought the best calculator in for $166, but it depreciates at 10.2%. So my 100% is decreasing by 10.2% annually. Okay, so that's decreasing at, or changing at a rate of 89.8%. Okay, so I'm going to take that 166 and I'm going to multiply by 0.89898. That's percentage. This is decimal form. And then we're going to do that every year, so for 15 years, and that should get us the 33.06. Okay, it's the same thing as using that formula. The face value or future value, present value, 1 plus r over 100 n or t. Yeah, it's n. So here again 166, but it's depreciation, so we've got to change that plus to a minus. Okay, and you would have gotten the same thing. Okay, it's the same idea, just different, logic it out or use the formula. Same idea. 18. All right, so we're going to assume the inflation rate stays the same. So for 1.2% every year. So we want to see what happens 4 years from now. So in the first year, my present value is $30. I have 1 plus, it's increasing at 1.2%. And we want to do that 4 years. Okay, we solve this and we should get 31.47. Alright, so Randy inherited this. Now here I would use my calculator. So, okay, so I want to fill out these parts of my calculator. Alright, so he's given $23,000, so he decides to deposit into an account. So putting up $23,000, and the interest is 1.8%, and we want to know what happens in 10 years. We don't have anything going on with payments or compounding. Oh, and I don't make those 0. That would not be good. You want to make it 1. And then you do alpha solve for this. Do alpha solve for this, you should get that. Okay, so let's do it again. I try to do these pretty basic. Okay, so we start with 250,000, and we're doing each month at an interest rate of 0.3. So each month is 0.3%, but we're doing it for 25 years. So it's not just 25, it's 25 times 12, because we want to do it each one of those months. Okay, I'm not dealing with future value, payments per year, compounds per year. I'm just going to ignore that stuff. And I'm going to do alpha solve for payment. Okay, and then that should tell you how much she's getting paid each month. Okay, so hopefully that makes sense. If you have any questions, please come talk to me in class. I got a lot of time in there, ready to answer any questions.